Welcome back to Finite. What can I say? So be sure that you're, getting your work done as best as you possibly can. Going forward, I'm not super concerned with due dates at this point. I mean, we have the looming due date of the end of the semester. So a few people have a few things going on. I understand that. Some people have internships. Some people they just have various things going on. I've tried to be lenient with that kind of thing, but we have the overall looming deadline coming up. So I'm going to let everyone kind of manage their own time up to the end. So just be sure that you are getting things done in a timely manner. I'll also say, I want to say this as nicely as I possibly can. So if you have something else going on, I'm there with you. Okay, I have other things going on too, and I'm there with you. I cannot, for anyone in any of my classes, give some kind of waiver for homework or anything like that. I've gotten some requests for that, like, I wasn't able to get to that. Can you waive that, or can you omit that from the grade book? I cannot admit things from the grade book. That's another way of altering grades, right? Giving you 100%. So I can't do that. I can manipulate due dates though, okay? That's okay. I don't have a problem. You need to pick something up on tomorrow or something rather, you're graded on your work. I can't just play favorites, okay? If I was gonna play favorites, I'd probably play it from the people that come to class, but I still can't, believe it or not. All right, so just want to say, just for the record, while this is recorded, I can't admit anybody's grades for anything. Okay? I can't just wave things away. That's not how it goes. I don't know if your other teachers do that. I'm sorry if they do, but I can't do that. Certainly can't, and I will not do that. Right? But I can be lenient on due dates. That's not a big deal, right? You're still doing it. It's still you doing it. So be sure that you're just doing it the best you can. I understand that many of you have things on. So yeah, so keep up with the homework. Another thing I just want to mention, just in case as time has gone by, you've forgotten, please recall that, just in case, I don't know, I think I want straight to. Just be sure that you are noticing that I'm posting things under the announcement. So just to be clear, it's not required, but I just want to make sure that you have it if needed. All of the lecture videos are being posted under the announcements. My notes are being posted under there, and anything, I try to take snippets from the textbook if I'm using the textbook for something, and then all of the bonus content that I mentioned, and in case you're interested, that's all being posted under announcements. And that has continued to happen. So when you go back and you have to start reviewing for the final exam, that's where you will find it. Okay, so if you're looking back and you're trying to find those videos or those notes or whatever, that's all posted under announcements. Okay, so I just wanted to remind you, just in case you guys are finding this helpful, that is where it's located. Okay, just wanted to mention that. What else should I mention? I already accidentally said the F word in class, final. I don't really want to talk about the final because that's not for a while. But since I invoked its name, I guess I'll mention the schedule for the class. We are on, ignore my other class. we're on the 18th, right? Today's the 18th, so week 6 stuff is due this week. The content we go over today will be due a week from today, and then on the 30th, everything is due. Everything is due. So if you're behind on something, you got to get it all done by the end, right?
Do we have class on a week from today?
You will have class on, yeah, we'll have a review class next week. And we'll talk everything there is to say about the final exam next week. How many questions, what to expect, what should we review, all of that. I'll have a full lecture on the final exam and what to do and how to do it quickly. Okay, but that's the schedule. So, less than 2 weeks, right? Because we have to be done by the 30th. Yeah. So hopefully things are going well. Many of you have been very communicative over email and messages, and continue to do so. If you're having trouble, if you have questions, if you're whatever it may be, please just email me. That's the best way to get a hold of me. We can deal with it. So don't hesitate to send me a message. But yeah. Okay, so I think I'm sharing my screen now. Okay, so week 7, what is it we're gonna learn? This is kind of the last week of new content. So week 7, what are we gonna learn? Last time we're really getting into the probability. We're getting into probability, we're getting into last week we did Markov chains, different states, that kind of thing. Now we're almost touching on statistics and probability involving statistics, which is very hot right now. I don't know if that trend will continue over the next 10 years. Only a fortune teller could say that. But the trend is towards this material. So there's a lot of jobs like data science and that kind of thing. So the trend has been going towards this kind of content with a lot of software jobs, data analysis. So this has a lot of practicality, very lucrative. So if you're going into computer science, you're going into any kind of science, even biology, chemistry, anything like that. This is a good thing to keep in the back of your mind of things to look up when you're going in the job market when you graduate, because this has become a very fruitful idea. So what is it? What is it? Well, we can analyze large amounts of data and start making predictions on it. And we'll do very simple examples in our class, right? This is an intro level university math course. So we do intro, but you can still do quite a lot with what we learn. So I'll show you a few things that we can do on the computer, a few things we can do by hand, and then hopefully they'll all kind of come together in the end. So if you've never taken statistics, don't worry, right? You don't need to have taken statistics before. Everything that we need is baked into this course. So there's nothing outside that we really need. I'll show you a few tools that you could use to speed things up, at least for the homework. And we'll just kind of take it as it comes. And don't hesitate to ask questions as I go along. All right, so let's do the first few problems in order on 7A, and it says construct a frequency table and a histogram for the following data using a class interval width of 2, starting with 0.5. What is with these widths? So you have data. I'm a teacher, so I always think of these exams, right? If you want to sort out exam scores, you can create some width to kind of come up with a histogram or come up with a way to understand where people are landing as far as exam goes. And then as the instructor, if you decide to take the curve, you can kind of take it as it is. Now, what's with these widths here? They tell us they use this width, so that's the one we have to use. They say, here is my width, so 0.5 to 2.5. All right, so I just want to know how many of the data points land within that interval. Okay, so 0.5 to 2.5, how many land? Well, 1 lands there, and I don't think anything else does. So there's only one of them that lands there, not the number 1, but well, coincidentally is the number 1. And then the frequency is, well, how many do we have? We have 1, 2, 3, 4, 5. We have 10 points. And we have the frequency over the number. So for us, that's 1/10. See, 1/10. It's not super complicated. We're just seeing how these things land, right? If we make an arbitrary width, okay, if it was exams, we might call it grades, F, D, C, B, A, see where people are landing, or you can even subdivide in there. But that's the idea. So you're just seeing where your points are landing. I think that's fairly straightforward. There's nothing really to calculate other than I just added up how many points I have. Then I want to pick the histogram. The nice thing is we don't have to make the histogram. We're just picking which one works for us. Which histogram is representative of the above data? Well, for me, I had the most in the middle, and so I picked that one. Yeah, so I just picked the one that represented the data the best. There was no, the nice thing is I didn't have to make it. That could be, very time consuming depending on how much data you have. If you have to make that by hand, that can be time consuming, but we only had to pick it. Okay. So histograms, you've probably seen that before. We don't dive too deeply into it, and I think at this point, it should be self-evident of what it is, but we're just looking at data and seeing how it's. The width can be helpful here. They just gave us the width of the interval, but that can be kind of an art of determining what your width size should be, but it can be very helpful in seeing how your data is going. Okay. Again, number 2, graph the following data using a bar graph. Okay. So they gave me revenue, they gave me corporation. I just had to pick the graph. So I didn't have to work anything. I didn't have to make anything by hand. I just looked at these values here. Okay, looks like it's starting up and it's kind of going down. Something like that. So I didn't have to make the histogram. I just had to. That's fairly easy. Not too bad. Very similar, just had to pick the corresponding graph, graph the data in the following table using the broken line graph. So I just had to identify, I didn't have to actually make it. And so I see 36, 38, so it goes up a little bit, and it goes down, 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 down just a little bit. So wasn't too hard to piece that together. The calculus class, we have to determine what those slopes are and construct the derivatives and second derivatives and all of that. Here we're just identifying, okay, it's just going up and down. So just getting reacquainted with graphs and data. Nothing too difficult so far, just kind of warming up. Okay, 32 people were chosen at random from employee of a large company. They commute times and hours were recorded in the table shown to the right. So I'm given a table of data, and that is fairly representative of what you will be given from a corporation. They've taken this data, or maybe you'd be the senior person, and maybe you are the one that actually implemented getting the data, but really you're just going to get chunks of numbers, right? That's what we're going to do. They have the class interval here. They want us to give the frequency, and they want us to give that relative frequency, which is just the amount over the total, the amount over the total. Note that in the homework, or at least mine, it says I can copy that to a clipboard, or I can open it in Excel. It gives me that option. I say, why not? Okay. So I'm going to open it in Excel because I can. If you have Excel, great. If you don't, I think you can easily do it by hand. I've done these problems by hand many times, but I want to show it in Excel for those that are interested. Okay. So I opened Excel. I think you can see if I shared my screen right. Now I closed everything. Okay, I think you can see Excel. It opened up and it just has all of the data in column A. So it gave me all of the information in column A. Now I can have Excel sort that data. So what I'm going to do, I'm going to highlight column A. And I'm going to quickly remember how to do this. Where was it? Sort smallest one. So I can have the computer sort the data. That's really helpful since it's asking me about intervals. I was able to sort the data and see if I can show you both. I'm slick, I can do it. Okay. So I was able to have the computer just sort the data for me. And then from there, I was able to go, okay, well, how many do I have between 0.15 and 0.35? Well, it looks like I just have 2. Obviously, on the left-hand side, Excel was counting how many I have total. So then I'm able to find out what the denominator would be. That can really speed things up. And since MATLAB offers that, might as well use it. If you're using a Mac, of course, you can use Numbers, the program. That shouldn't be the problem. Or Google Sheets or anything like that. And you don't even have to use this at all, but I just thought I would show it since it offers it. I might as well. So we can see how many points we have. We have 32 points. So from the interval of 0.15 to 0.35, we have 2 over 32, or 1/16, right? So we have 1/16 there. 2 over 32 equals 1/16. So not so bad. Just counting how many are in with that interval. Too bad. Which of the histogram represents the given data? Well, we can just tell from the frequency how it's working out. So by frequency, I was able to determine which one is the right choice. I didn't have to make the histogram. I just had to identify it. Looks like I have kind of a high point here in the middle. So I was able to identify it. It's my histogram. Again, you don't have to use Excel. You don't have to use a spreadsheet program. But since the homework offered it, I thought I would at least show you how you could use it. The other way is just to sort it out by. So what is the probability that the person chosen at random from the sample will have a commuting time of at least 1 hour? That is, the n is greater than or equal to 1. Okay, so what is that probability? N is greater than or equal to 1. So how many people are greater than or equal to 1? You can either do this by hand, this person, the 1. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Looks like 11. 32 total. I would reduce that if possible, but that is fully reduced. Oops. I want to write that here. Okay, what about less than or equal to 5? This, that one. Less than or equal to 5.5, sorry. Six. There. But still, just count. I would reduce that if possible, but I got 6 over 52. Just counting. So nothing too advanced so far. But we could imagine, you know, if this was Netflix and this was considering hours spent daily by users or account holders, well, we might, you know, they might be interested in what is the average time spent, or how many people, what's the probability they spent less than a half an hour on our platform, that kind of thing. We could extrapolate more information with more context. So just counting so far. I think I wanted to talk about 5. Yeah. So we're going to introduce some concepts of statistics, but luckily it's not too bad. So here it says, what is the mean? Find the mean of the data set. Okay, I don't know if you learned this in school before, but there's a lot of different ways to say that same word using different synonyms. So one of them in statistics is to use the letter mu. That is often used to mean the mean. The textbook also uses X bar to mean mean. It's the same thing. We also will write AVG for average. The average is the same thing as the mean. And mean are all the same thing. Interchangeable. Those are all interchangeable. You can also write it this way, and I think maybe the book writes it this way. sometimes it writes it with that summation notation. We don't have to worry too much about this because you're not going to actually use that, but this just means to sum up. This is a way mathematicians just writing to add. You can think of that fancy big E there as just an adding machine. So it just means to add all these points. But it's the same average you learned, way back in middle school or whenever. So let's just find it. But I wanted to kind of give you a preface that these are interchangeable and certain problems will use certain notation, but they all mean the same thing. So to find the mean, what is it? How do you do it? You just add them up. And then we divide by how many we've added. So that's 1, 2, 3, 4, 5. So I have 5. 5 over 5, which is 1. This is the mean, which our textbook uses this X bar notation. But there's many different notations to means. You can also do this in Excel. Can I show you how to do it in Excel just in case you're interested? Because you might be interested when we do problem 12, when it gets hard. Let me just show you. You can ignore me if you want to. I'm gonna plug this in. I have 4, -6, -3, 4, 6. And I'm gonna have Excel just calculate the mean for me. I'm gonna write the word mean for myself so I remember what it is I'm doing. If I want Excel or numbers or Google Sheets or any of these spreadsheet programs to calculate something for me, I can hit the equal sign to wake it up. It says wake up, okay? And you hit the equal sign, it says, I'm gonna have you calculate something. And I'm gonna start typing the word average. And it already knows, it's saying, are you thinking about taking the average of something? As a matter of fact, I am. So I'm gonna take the average of these numbers. I'll just highlight those numbers. Highlights them. It says A1 to A5. I hit enter. It tells me the average. So I've calculated this by hand, and I've used Excel to calculate this, or numbers, or Google Sheets, or LibreOffice, or any spreadsheet program. They all use that same notation in theirs as well. So you use the equal sign to tell it that you want to calculate something. You don't have to, but I think it's of good practice to at least write for yourself what it is you just calculated, rather than just having numbers everywhere. All right, you don't have to do this, but I think it's worth knowing that you could do it if you want to. You can also just use a calculator anytime you want. It's probably best to know both. But if you have a large amount of data, you're not going to do this problem. And if you go into the job market or something, you're going to calculate very large, like 10,000 points. Right? You're not going to calculate, 5 points. You're going to calculate thousands and thousands and thousands of points. And you're going to compare it against other data sets and compare those. So it's good to know. It's good to know what it is you're calculating, what that means, and it's also good to know how to use a computer. And then going forward, you could write a computer program by hand if it does this for you. All right, mean, median, mode. Right, we just talked about the mean, so we know how to do that. The mean, which the book uses X bar, we just add it up. 3, how many 3s I got? 1, 2, 3, 4, 5, 6. How many do I have? 1, 2, 3, 4, 5, 6, 7, 10. Okay. 8, 9, 10. That's the idea with the mean. Of course, we can have the computer do that for us. We can also do it by hand, no problem. What is the median? The median is the middle number. It's the middle. The issue with finding the middle of the data set is that means there has to be some kind of order. If you have large amount of numbers and you want to find the middle number, not the average, but the middle, then you have to put them in order, okay? And these are in order. And so our middle is actually right there. It's between, well, at least with my numbers, it's between those two threes. So the middle is between those. So it's the average of those. 3 plus 3 is 6, divided by 2 is 3. So my middle is 3. It's the middle number. But if it's the middle number, that means they have to be in order. So if you're doing this by hand, when I teach lower level math, this is something we work on, where you put the numbers in order and then you just find the one in the middle. But again, if you're going to learn, or if you're going to use this large amounts of data, well, you're going to use a computer, and we can use a computer to find that for us as well. Excel knows how to calculate that. All right, let's identify the modes. Let me switch colors to the one. So the mode is the most occurring number. The number that occurs the most. You can have a data set that has no mode. Nothing occurs more than any other number. You can also have more than one mode. That's possible. You have to define what you mean by mode, and I'll tell you what I mean by that. But in mine, 3 was the number that occurred the most. The number that occurred the most was 3. The number that was in the middle was a 3, and the average or the mean was 3. That's the idea. So we have to understand what this stuff is referring to, what this all means. But again, you can have that self-calculates for you. So I can have Excel calculates. Well, I can find this space on the screen. So I can have it go, okay, calculate the mean for me. So equals average, highlight the data, to enter 3.8. Median, equal sign, guessed it, just write the word median. Highlight what you want to find. And found the median was 3. The mode, RDE, equals mode. Here, it wants you to specify, do you want a multiple mode or do you want a single mode? Okay. I'm going to have it do multiple since I know my options, it can have more than one number. I'm going to choose multiple is fine with me. Then highlight the data. Found the mode was 3. So the computer can do that. The nice thing about the computer is that it's happy to do, you can have, like I say, 10,000 points. Imagine what Netflix has. Imagine what Amazon has. Imagine what Google has. Imagine what they have on just a single user, let alone all of their users. So they're doing it with a computer. They're not doing it by hand. Okay, those smarty pants, they know what mean, median, and mode means. There must be a reason they're calculating because they want the average. They want to connect users to find probability and advertise to them better. But The idea is there. So you can do it very easily. And then, of course, if you know a little bit of computer programming, you can write something pretty quickly that can do these as well. That's not too bad. But the mean is the average, same average we learned in middle school, maybe even 5th grade. The median is the middle number, which means the data has to be in order to find the middle, and the mode is the most occurring number. These are the ideas, basic statistics. Now, I think this was just, is this just a multiple choice? Yeah, there wasn't much to do. So find the mean, median, mode of the car color, whichever is applicable. We have car color, number preferring, car color, number preferring. Here it's a little strange. I'm kind of glad that the homework goes over it, but there isn't like an average car color. There's not really, it doesn't really apply to what we're looking at. So you can't have an average of everything. Like it doesn't, you have to be a little specific of what it is. So for this, because we just have different amounts of cars and different color, there wouldn't be a mean car color. That wouldn't quite work. So I claim there is no mean. Right. If there was, what would you do? You'd add up all the numbers and divide by how many. Oh, but that's not going to quite make sense. Determine the median of the car color. Well, there isn't a median for car colors. Okay, that's not quite right. There is no median. Determine the mode. Well, there is no mode. No, just kidding. It's white. That's the most occurring number. Most occurring number. But we can have that. But we can't have an average car color. Okay. Average car color is red. Doesn't quite make sense. So the mode was white, the most occurring number. So I think the homework is just trying to remind you, at least make, there has to be a reason that you're calculating these numbers. You can't just arbitrarily add them up. Okay. I think this is also just a multiple choice question. Given the following data, explain why the mean would not be an accurate representation of the numbers. The mean would not be an accurate representation of the number. 97 is an outlier. So why are they saying that? So I chose that 97 is an outlier out of this data set. Okay. It seems like something's going on. Matter of fact, sometimes in the past, when I've entered in a student's grade manually, not in your class, but in one where I've graded by hand, sometimes I would enter it in incorrectly, or I would enter a percentage when I was supposed to enter a point value or something. Like this is 18 points. If I would have given the student 100, the computer notices that that's quite a bit higher than the other students, and Canvas actually warns me about that. So that can be nice. So the reason is because this is skewed very high. So this is an outlier. It's not to say that you can't have outliers in data. Of course, you're going to have data. Generally, you have 15 or 16 people. You're going to have one person that's very low at whatever you're gauging and very high. One person is very high. That's what I have found from teaching courses. And that generally is how things are skewed, even in a random set of people. This is also just a multiple choice question. Which single measure of central tendency, mean, median, and mode would you say best describes the following set of measurements? Discuss the factors, justify your preference. So you could plug this in a calculator, you could plug that in Excel, however you like it. But I think the median best describes the measurements. It does not affect by an outlier and accurately approximates the center of the distribution. Okay, because we have this 86.9 outlier. That's definitely going to shift. It might not shift median as much. So sometimes you have to determine what is best representative. Okay? And when you're in the field, it will make more sense because you'll have more context what you're looking at. So if you're looking at data samples from some kind of pharmacological test or user groups or employment rates or anything like that, context can really help with that. Number 10. I'm gonna get to the hard problems, I promise. Evaluating the data, and she's collected the ages of the students in their introduction to Western Civ lecture. She finds that the range of ages is 19. This means which of the following? The difference between the oldest and, so it's just asking us to define what the range is. The range, which is not in Excel, by the way, it's just the max minus, but I can show you where that is in Excel if you like. So if you go on spreadsheet, you can have it find the max. You can have it find the min. Equals max equals min. But it doesn't have a range. I don't know why, but it didn't program range. So what do? You just go max minus min. That tells you the range of the values. But in Excel, there isn't a range function for some reason. I guess because they thought, well, it's so easy to calculate it anyway. I don't know. I'm not sure what the point of not having it is, but it hasn't had it since I've taught this material. So since 2016, 17. Maybe next time. All right. Now we're going to get into it. So price earning ratios, find the mean, median, and mode for the following data, the table. So the mean, again, you can do this by hand. You can add them all up and divide by how many numbers you have. For the median, you just want to put them in order, find the middle, but you could use a spreadsheet program. And for the mode, you just want to find the number that occurs the most. For my numbers, it was 10.1. That was the number that occurred the most. Are there any questions about mean, median, or mode before I move on? Are there any questions of what those are, how I can calculate them, anything? Now would be a good time to stop me and ask, comment, or critique. Easy stuff, you think, can we do this one? This would be doable. Okay. I'm getting that yes, this is doable. So you can use a spreadsheet program, you can use just a regular calculator, however you like. If you're going to find the median by hand, you need to put the numbers in order. You put them in order and then just find the middle. If they're an even amount of numbers, then you find the middle of the middle. So any questions about mean, median, and mode? Online folks, are we good? That being said, let's do number 12, which will be confusing. Why is this one going to be confusing when the other ones I don't think are so much? In this one, the interval really kind of, it can really kind of wreck our confidence of what this stuff means, okay? So we have this interval. And what does the interval do? Well, before we just had values, right? We just had values that we needed to add up and then divide by. There wasn't any question. Here we have an interval and a frequency. So it's kind of both ideas at once. That's where it gets confusing. How on earth are we going to find the mean with something that's an interval and a frequency? How on earth? That's my question to you. How can we do that? How can you take an interval and a frequency and come up with a mean? So before, we just had numbers. We added up all those numbers and we divided by how many we added up. That was the mean. Now we have an interval and a frequency, and we want to find the average. What do we do with these intervals? What do you do with the interval? So we have to do something. How do you do it? Well, what I think we should do is we should find the midpoint of that interval. I think that would give us a number that we could work with. Because before, we just had a single number, we added those up, we divide by how many we added up. Now we have an interval and a frequency, which is how many times it applies. So you can think of like have some kind of bar graph here. Something like that. We have these intervals, we have an amount of times that occurs. And we want to find the average this way. How can you do that? I think we need to find the midpoint of the intervals. We can multiply that by the frequency and then divide by how many we have, and that should give us the mean. Does the plan of attack make sense? Does that make sense? So we have to understand what to do before we do it. We have intervals instead of just numbers, and we have frequency. Frequency is like the amount of numbers we have. Okay, so think this is this is life hours of 50 light bulbs. Okay, so we have some interval, and then this is how many light bulbs did. So if you added all of these numbers up, that's how many light bulbs you have, how many numbers you have. Okay, let's see what that is. So I'm going to sum the frequency. How many do we have? We have 13 plus 21 plus 12 plus 4. So I have 50. So far, so good? Okay. So I have 50 total. What do I do with these intervals? Because like I said before, I just had numbers and I just added them up and I divided by how many I had. Now I have intervals instead of numbers. So what I think we need to do is we need to find the midpoints. I think if we find the midpoint, then we can multiply by the frequency and that would give us the amount. So that's what I'm going to do. So I'm going to take the midpoint. I'm going to multiply it by the frequency. And that I'll be able to add up and then divide. That'll give me money. So far, does it make sense what I'm doing before I even do it?
What's the midpoint?
The midpoint is I'm gonna take this interval and I'm gonna find the middle. And then with the middle, I'll count that as the number. Like I had a bunch of 3s and 5s before. I just added up all the 3s and 5s and divided by how many numbers. Now I have intervals. So what does that mean? Well, really what I'm doing is I'm taking the average of the interval and I'm counting that as the number. And I'm going, okay, how many of those do you have? So it'd be like, we have some interval, we have 3 of them. Well, we're gonna count this as there. So I'm taking the average of the interval, that's the midpoint. Then I'll multiply these two numbers, I'll add those up and divide by how many I have. And that should give me my mean, because I want to find the mean. So I'll try to find. All right, so what is the midpoint? I have 799.5 plus 899.5 divided by 2. I found 849.5 as my midpoint. Okay, online folks, it's totally fine, but you guys are quiet and I'm just worried if this makes sense. Is it clear what I'm doing? Okay, because that's more important than actually doing it. Next midpoint is 999.5 plus 10,095 divided by 2. Frequency is 21. I want to multiply that by 21. Nine, nine, 5, 2. Frequency is 12. One 99.5 plus 2.5 2. Frequency is over. So what I've taken is the midpoint of the intervals. I rewrote the frequency. I multiplied those numbers. Now I'm going to add all of the midpoint times frequency together. Now I want to sum these up. Add those together, and then I'll take that number and divide it by the frequency, the total frequency. Very time consuming, of course. Very easy to make a mistake. You know how it is. So if I plug this in my calculator right, got this 52,875. Now I think we can find this. S dividing by the total frequency, which is just the amount of numbers we have.
Fifties.
50 was the total number of numbers.
The 3 plus 10.
Yes, just adding them up. So I summed up the frequency.
Okay.
They told me frequency, I added it up. Okay. That's a lot of steps, huh? Who on earth would want to do this by hand? Not me. Not me. Right? That'd be a way to speed this up, huh? Now we need to understand what it is we're doing. But maybe there's something. Maybe, not always, sometimes. So this week, in my lecture notes, in my announcement, I made when I was going through this homework, I was using Excel. As I was going through the homework, I made a spreadsheet to do my work, okay? And so here you can see my frequencies, switch colors. Here are my intervals, okay? My midpoint, this, I didn't do one for 12, sorry. I'm showing, I guess I'm putting the cart before the horse. But for 15, 16, 17, and 18, I use Excel spreadsheet to do it, right? I'm gonna give this spreadsheet to you all, okay? Not to cheat or not to have you just use my spreadsheet, but I just want you to be able to compare how it can be done in Excel with your numbers. And I think that will kind of help. So I saved it and I'm gonna share it when I post the notes. That way you have it. And in reality, that's how you do it. Come on the spreadsheet. You are going to make your proclamations to your committee, to the board, what you proclaim is the future holds, okay? But that's the idea. So that's by hand, that's how you do it. What is it we did? Because there's a lot of steps. Okay? So what is it we just did? We have intervals. So I found the midpoint of the intervals. We're given the frequency. That's how many times it landed in that interval. So I did the midpoint times the frequency. I found that product. I summed those products and I divided by the total amount of numbers. Okay. And that, I wager, is my mean. That is the average. Okay. A lot of steps. A lot of steps. Are there any questions about finding the mean? No questions about it? Any questions in-house about it? Does that make sense? Well, that's the easier of the two questions. Okay, so that's the mean, that's the easy part. The hard part is finding the median. How do you find the middle of intervals? How can you find this? What does that mean to find the middle of something like this? You want to find the middle of the information. Okay, think about where it comes from. It's coming from like a histogram. So you want to find the middle of this. How can you find the middle of something like this? How can you do that? So it's like finding the middle of the area. And they're just rectangles, right? Because it's just in this interval times this frequency. That's how high it goes. So let's say that was a 3. The area of that particular rectangle is what? It's just that interval times the frequency. Well, what is this interval? 799.5 to 899.5. That's just 100. So for that particular rectangle, the area is just 100. I'm sorry, say it again. That's 100 times 3. So the area of that rectangle is 300. What is the area of the total amount? What's the total amount? How many do we have? This was an interval of 100. What is this interval? How many is that? What is that? What is that? Okay, how many hundreds I got? 100, 100, 100, 100, 100. Okay. So I'm gonna write total. And I have 100 times 3 plus 10 times 100 plus 21 times 100 plus 12 times 100 plus 4 times, oh, not bad, go away. Plus 4 times 8. Okay, how many is that? That's just 50 times 100. Total is 5,000. That's the total area. It's 5,000. We want to find the middle. We want to find the middle. So where is the middle? Total divided by 2. 25. So that's the middle, is 2,500. Okay, that's the middle of the total area. How do you find that? So where is that going to lie? Where is our middle going to lie? It's going to lie somewhere in here. The middle will land somewhere in there. You have 3, 10, 21, 12, and 4. The middle will land somewhere in there. Where does it land? Where does it land? I don't know. So I have to calculate it. And I know this is really messy, and I'm really sorry about that. I didn't plan to go so messy. But let's calculate the median. Okay, so I know that the total area is 5,000. Half of the total is 2,500. So I want to find, where is it? Where is the median? Okay, so it is what? It's 100 times 3. That's coming from this interval and that frequency, plus 10 times 100. That's this frequency and that interval. And then the middle will land right there, but I don't know where. That's the annoying part. So what I'm going to do is I'm going to go the median minus that interval times 21 equals the middle. That's the idea. So I'm finding the total area. I cut it in half. Okay, that's the middle. Now I'm finding, where does that exist? That is just a simple elementary algebra equation. Okay, I have nowhere to write it, but that's what it is. Let's see if I can rewrite it. So that's 100 times 3 plus 10 times 100 plus m minus 9,995 times 21 equals the middle. And we want to find, where is this location? What did I do? I just subtracted these 25. You can divide by 21 and then add 995, and you get the median. So you just want to solve this. The only thing that will change from your question, from my question, I think, is the frequencies. I think that's the only thing that actually changes. Okay. That's a lot. But it is a lot, so there's not much I can do. That's pretty complicated stuff. What questions do you have for me about that? Is there any part I can go over again?
the n minus 999.5 is the frequent or the interval, right?
So that's coming from, it's landing somewhere in here. I don't know where, but that somewhere in here is the middle. Somewhere here is the middle. So that's the beginning of the interval. To where? To what is the middle? I don't know. So I just call it n. So I'm just saying, okay, I don't know where it is, but I know it starts at 999.5 to the middle. That's my idea. So the start of the interval to n. Where is that? I don't know. So I had to set up an equation to solve it. Now the good thing is the textbook does a good job of explaining it. So you can go and you can cut through this, and it pretty much does the exact same steps I did. So you have some backup there. So that's good. That's the good thing about my faults. That's the idea. The question was, I think why did I start with that interval, or
Yeah.
was that the question? Why that one? So that's the middle. I know that's the middle, but where? It's lying somewhere in here. I just don't know where. So I know it's in here somewhere. I just don't know where. So I started with the interval that I know it lies in. And I just go from the start to the midpoint. Where is that? And I set up my equation and solved. That was the idea. Median is one of the most annoying things to have. Maybe in my opinion, almost the whole class. When I took the job of teaching this, I was like, oh, I knew it from signing the contract of teaching the classes that we're gonna have to do. I knew it. It's annoying, but it's okay. It's okay. It's not too bad. You just gotta follow the steps, right? So for that one, we did it, I would say roughly by hand. We'll use a calculator, roughly by hand. We didn't skip too many steps. So I'll post that later. Then I'm gonna go over 13 or skip right to 15. I can say this is pretty much the exact steps. Okay, you have backup, you have view an example, so you have backup. It's pretty much the exact same thing. Okay. So you have your intervals, you have your frequency, the same thing. The mean, same steps, follow the same steps. And you have median, follow the same steps. Okay, so that's pretty much the same thing. And since we're already at 10 after, let's peek at 14. The mean, honestly, for this, I think for this number, which is 14, we can just go back to the old way. We can just go back to the old way. There's no intervals there, just numbers. So for there, you can just add the numbers up and divide by how many you have. And for the median, you can just find the middle number. So no problem there. The mode is just most occurring. So it's only when we have those intervals we find ourselves with a little bit of a headache. Thank you for letting me know, Jessica. Okay. So I think 14 will be okay. That's pretty much what it was before. The intervals are the tricky ones. Okay, 15, it looks like it's going to be an easy problem, and oh boy, it's annoying. I'm sorry to say, it's tricky. Find the standard deviation for the set group to the sample data. I'll show you how we can speed things up, but I'm going to also try to teach you what this means. What is the standard deviation? Standard deviation is how the data is spread out. It's the spread. Okay, it's the deviation. It's the spread. Okay. When I'm grading exams, looking, not so much for you guys, but for other classes when I have to grade it by hand or I'm looking back on my content, especially exams I wrote for myself, I see how are these students spread out. Okay? And what I found is, over the years, when I teach in-person classes, they have a very small standard deviation. The students that come to class, they usually, there's top students and bottom students, but they're very close together. Online students are very spread out. Okay, you'll have people that are getting 100% on everything, and you'll have people that are getting 10% on everything. It's extremely spread out. And that's because it depends on what information they're consuming and how much. Okay, so standard deviation is how it's spread out. If we're thinking of Netflix or Amazon users, how often are they using the service? Okay, that's the idea. So this is how it's spread out. But the tricky thing is now we have this stupid interval, and that's always when it gets nasty. When you have the interval, you have to kind of take a deep breath. So the first thing we want to do is we have the interval. Let's find the midpoint. If we find the midpoint, then we can use that midpoint in our calculations. So we have we'll have frequency, and we'll have mid times frequency. From there, we'll be able to do something. All right, what is the midpoint between 0.5 and 3.5? What's the average between 0.5 and 3.5? Just a pulse check. Somewhere two. Okay. 3.5 to 6.5. I think that's 5, 8, 11. Okay. Just finding the midpoint. Now I'm going to multiply that by the frequency. Okay. Because I'm going to have to find the mean. Find the standard deviation, I have to find it. So let's find it. All right, that's 2 times 6, which is 12. 5 times 5 is 25. 8 times 4 is 32. And 55. Okay. So I need to add up those products. 12, 25, 32, 55. I found those to be 124. Now, that's like the total that we found before. Let's sum up frequency. I found that there was 20. So the mean is the midpoint times the frequency over the number. So what do you get? I got 124. Which I found to be 6.2. So I found a mean of 6.2. It's asking for standard deviation, but to find standard deviation, I have to find.
And 124 is from adding up.
I added these up. So that's the mean. How do you find the standard deviation? So here's the formula for standard deviation. It uses S. A lot of times we use sigma. It doesn't matter. Here's the formula. So we want to add up the square root of, for us, it's just going to be the midpoint. So I'm gonna write midpoint. It's kind of small, but I need the room. Midpoint minus the mean squared divided by n minus 1. So we need to calculate the midpoint minus the mean squared divided by n minus 1. What is n? N is the sum of the frequency. Okay, so this is n. N equals 20. That's probably the thing that's going to randomize between questions. Okay, so let us do that. So we need to calculate the frequency times the midpoint minus the mean squared. Need to calculate that. What does that mean? For this number, that's 6 times the midpoint, which was 2, minus the mean, which was 6.2. I'm going to square that.
Mid minus what?
Mid minus mean. Let's actually do it. So 6 times 2 minus 6.2. I'm getting 105.84. Next one would be 5 for the frequency, 5 for the midpoint, 6.2 for the mean squared. 5 times 5 minus 6.2 squared. 7.2. Next one, frequency is 4. The midpoint is 8 minus 6.2 squared. 4 times 8 minus 6.2 squared. It's 12.96. My last one, my frequency is 5. Midpoint is 11 minus 6.2 squared. 5 times 11 minus 6.2 squared. 115.2. Now I'm going to sum those up. That's what this symbol means here, is to sum up, add them up. We got to add them up. All right, so let's do that. 105.84 plus 7.2 plus 12.96 plus 115.2, 241.2. Okay. 241.2 over n minus 1. What's n? I had 20. I add up all my frequencies. That's how many numbers. That's n. I subtract 1 by definition. Need to do that. So 241 divided by 19 equals 12.6947. Rather than that, need to square root. Because right now that 12 is the variance.
Why are we subtracting 20 minus
That is by definition with n minus 1 there. And the reason is actually to take away the error. That is the standard deviation. Okay, that's how it's spread out. But subtracting the 1 is to take away the error. We'll just say that. That's a lot of steps, right? A lot of steps. Each step is not that bad, but that's a lot, okay? Especially for one question. Find the standard deviation. Is there any way you can speed that up? Well, what I did was for 15, I plugged all of this into the computer. So I plugged it into Excel. I plugged in my intervals, and I just had it average it. So really all I had to do was plug in my intervals, and then I just had an average. I pulled it down and was happy to do that. I entered my frequency. I had to enter that in my hand. Midpoint times frequency, I just found, had it take the product. And I knew what formula I needed. So I just had to calculate that one. I just plugged it in. So you can see that's doing it. Calculated the sum of the frequency, calculated the sum of the products, calculated the sum of the mid minus mean squared times frequency. And then I did it piece because I had a feeling I was going to show you this. And then you take the square root and you find it. Okay. You can also see how I calculated the mean there. Right. So you're going to have access to the spreadsheet. I thought maybe I would show you that you could do this on a computer as well. I'm not giving it to you so you can cheat, but I'm hoping that since Excel is not really important, I think you can kind of gain something from seeing it. I hope you can, because that's probably how it would be done in the field, right? It's going to be done using Excel or spreadsheet. All right, we're already 22 after, and we're still in the first section, but you know, this stuff takes a lot of work to do. Here, kind of back down to it. We don't have to deal with the intervals, so we can take a sigh of relief. You can just add up all the numbers and divide by how many numbers you have. That is your mean. For the standard deviation, well, you can, do what we did by hand before. You can take all the points, subtract from the mean, square that, and then divide by how many you have, take the square root of that, or you can just have Excel quickly do it for you. I entered this in, and Excel has a standard deviation as well. That can be really easy. If you have a TI 8384, this also has finding standard deviation, finding the average. You just need to plug in a list. Okay, so you have to do list view. I have some videos posted in the modules if you're interested in that. But for that, you just need to make a list and then ask the calculator to find the mean and find the standard deviation using that list. But that's not too bad. I have a video of the step-by-step instructions posted in the modules there. Here, once again, we have intervals, so we know that's kind of annoying. I used Excel to solve it. It wasn't too bad, especially once I had one built. The second one's pretty easy to build, but the intervals is the tricky thing. So that's usually the tricky thing. Then 18, back down to easy stuff, since everything is just single number. I just add all numbers up, divided by how many numbers I have. That's median, then standard deviation. I think, honestly, I just entered it in Excel. So there's 18 as well. So I'll give you that in case you're interested in looking at that. That'll be posted in the announcements this week. Okay. All right. Well, I hope that's a good enough introduction. 7A, it definitely has some easy problems. The first few are very, very easy and straightforward. The other ones can be quite laborious. So it definitely is left skewed. You know what I mean? All right. Any questions about that? Any questions, comments, concerns? All right, I'm gonna take a 10-minute break. We'll come back. We'll talk about 7B. Are you back? Are you back? Can you give me a hi, a low in the chat if you're back? Log that you're there. Okay. I mentioned it, but I didn't show it. Let me, just in case you're using a graphing calculator, let me try to show you how we can do some of that in the calculator really quickly. Hopefully really quickly. We'll see. All right. So what we want to do is we want to manipulate a list. So we want to make some data. On this, see the problem with all of the calculators will do it. It's just finding where is it, what button do you press. So we want to go to list. So here I'm going to go second list, and I want to edit a list. I want to just like a matrix. I want to edit this stat button, and I'm going to edit that list. On the break, I just put some random numbers there. Just something that we have to play with. All right, so I have a list of numbers. That would probably be the numbers you're interested in. From there, I wanted to calculate. Okay, so I'm gonna go to second list again. Now, let's say I wanted to calculate the standard deviation of the list. Select standard deviation, and I can go back to list, select the list I want, and it'll just find the standard deviation. And also have it find the mean as well, the median, just like we did with Excel. We can do this here with the list. That's it. So the calculators can do it as well. You may have seen that in high school. I don't know, but it's still there. Okay, and then you can use Excel or any spreadsheet program, and it does it differently, but just as well. So you'll have access to that during the test, because you can use calculators during the test. All right, let's talk about 7B, the last new material. Next week we will review for the test. But here, what we're doing is we're extrapolating the idea that if you do the same experiment over many times, that's really a binomial distribution, a normal distribution. What we were doing with histograms. So if flipping a coin it's 50-50 each time, so you can flip a coin 100 times and you would still get, each time it doesn't matter on the previous time. So this is the distribution, okay, of how many heads or how many tails you get. You'll have a normal distribution of this. That's the idea. So this really is kind of the culmination of what we've been doing. So in some ways it's a Markov chain, and in other ways it's a combination. We study combinations. So we're really putting it all together now. Now, here it says a fair coin is tossed 5 times. So that's like n equals 5. What is the probability of at least 4 trials? At least. Tails. Oh, goodness. Tails. At least 4 tails. So it's heads or tails. Okay. How can you do this? Well, you could make a tree, but that would be pretty ugly. Pretty ugly. Why do I say that's pretty ugly? Because 5 times, that's each time it's going to give you 2. Right? So you're going to go, and this is what not to do. But at least we can visually see what's going on. So just flipping it twice on here. Flipping it 3 times here. This is going to exponentially grow. We don't want to have to use a tree for this, especially since it's so repetitive. So what can we do? So we don't want to make trees for this because each one is just 50%. And even in my example, I haven't got to 5 flips because I don't want to do it. That's only 3 flips. That's 1 flip, 2 flip, 3 flip. But this graph grows exponentially, so I don't want to have to do that. So what can we do? Since it's the same probability of getting the tails each time it's the same, and we know how many times we're flipping it, maybe there's a way of just calculating. So we're flipping it 5 times. We want at least 4 tails. So how many tails out of 5 flips is that? That would be 4 tails and 5 tails. That's 2 events that could occur. So we want to find all of the different combinations that could do that. And then we want to multiply that against the probability. So there's many different combinations that would have 4 tails, right? You could have tails, 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 heads, tails, and so on. Move all that. We don't want to have to count all that. We have formulas to do. So that's a combination. Do you guys remember combinations? So I think to count all of those different ways that could happen. Thanks, Jack. All the different amount of ways that can happen of 4 tails out of 5 flips, that's 5 choose 4, which we can also just do in our calculator. Okay, what is the probability of getting a tails? Well, this is a fair coin, so it's 50-50, right? So 0.5. Okay. How many times are we getting the fair coin? Like for instance, how many times are we getting tails? So let's say you're going tails, tails, tails. How many different ways can you do it? Well, each time you're going to go 0.5 times 0.5 times 0.5 times 0.5. Each time. How many times are you doing that? You're doing it 4 times. So I think you would have an exponent of 4. Now, you're also going to get some heads. How many are you going to get? You're going to get 1. Because right now I'm just calculating 4 tails. What's the probability of a head? 50%. So here, I have the probability of the tail, because that's what they were interested in. I have the probability of a head, which is the other outcome that can happen. And then the combination is how many ways. So this is a formula that we built, and this formula will count what's the probability of getting 4 tails. Now it said at least 4 tails, not exactly 4 tails. So I need to also do the event where we get all tails. So that would be 5 choose 5, as in there's only one way to get all tails. 50% chance of getting a tail each time to the 5th. That's the idea. That is the idea. Okay, we can simplify this quite a bit more. 5 choose 4. Do we know what that is? Do we remember combinations? Does anyone remember combinations? How do you calculate combinations? This was the material that I pre-recorded, so I hope it makes sense. So I think 5 choose 4 is just 5. You can also plug it on your calculator. variance for this. So I can simplify this. This equals 5 times 0.5 to the fifth plus 0.5 to the fifth. Okay, what does that equal? 5 times 0.5 to the fifth plus 0.5 to the fifth, 0.1875. It wants it as a fraction. There's a lot of variation that we can have with that problem. Right? It could be at least 3 or at least 2 or at least 1. There's any of those changes would drastically change the problem. Are there any questions about how I found this? I saved a picture of it in case you want to look at it later. 2. If a baseball player has a batting average of 0.32, what is the probability that the player will get the following number of hits for the next 4 times at bat? Exactly 2 hits, at least 2 hits. So the next 4, so that sounds like 4 trials, exactly 2. I don't know much about baseball, but it looks like we're doing 4 trials, and 2 of them want to have it. Okay? So the amount of ways that can happen is 4 choose 2, which is 4 times 3, which is 12 divided by 2, which is 6. So I think 4 choose 2 is 6. All right, what is the probability of them hitting the ball? Well, they gave me that was 0.32. How many times are they hitting it? In this case, they're hitting it twice. And then what is the probability of not hitting it? 1 minus 0.32. How many times did they not hit it? 2 times. So that's the sometimes called the probability of failure. Okay? Or it's just the complement. So I just wrote it as 1 minus 0.32. So hopefully you can see where that comes from. Okay, 4 choose 2 times 0.32 squared times 1 minus 0.32 squared. .2841. Rounding there, but that's exactly 2. Any questions about that? Next, at least 2. What does at least 2 mean? That would be 2, 3, and it goes up to 4. I just calculated 2, so I have that. But it sounds like I also need to calculate 3 and 4. Okay, so I'm going to do that next. Okay, so I need to calculate 2 hits, 3 hits, 4 hits, because it's at least 2 hits. All right, so let's do it. So that would be 4, choose 3, 0.32 to the third, 1 minus 0.32 to the first. They have to add to 4. That's the total number of trials. So what does that equal? 4 choose 3 is just 4 times 0.32 cubed times 1 minus 0.32 to the first. 0.089129. And then the other event that could occur is we hit 4 times, 4 out of 4 times. That's just once. There's only one event where you can hit it all 4 times. What's the probability of hitting the ball? Well, that's what they gave us. We hit it 4 times. And then for the complement, 0 times. So that just goes to 1. So this just goes to 1. That just goes to 1. And you're just left with 0.32 to the 4th, or whatever number they gave. Okay. So we need to add these 3 numbers together, and that should give us at least 2 hits. 0.2841. 76. I did something wrong. Green. Sum these up. We got 0.384. That's at least. At least. But for me, it only went up to 4. It could change. I think it randomizes it sometimes. How do you plug these equations into the calculators? So for this one, this calculator, we like, I think you can go to math, probability, and choose R. That's what we want. Okay. So let's do that. Which one did I use? 4 choose 2. So 4 math. Choose 4 choose 3. I just knew if they're 1 away, that's just 4. And 4 choose 4. I just knew it's 1. But you can plug in the calculator. Does that help with how you plug in calculator? In truth, I'm using just a little Casio. Any scientific calculator has it. Any other questions? Thank you for participating. Any other questions? Keep going with it. Number 3, a random variable represents the number of successes in 20 Bernoulli trials, each with a probability of success of 0.55. Find the mean and standard deviation of the random variable. Part B, find the probability that the number of successes lies within 1 standard deviation of the mean. How do you find mean and standard deviation with trials? How do you do that? So there's no intervals, so I'm not too scared yet. This is going to be a nightmare. I know the probability of success, 0.55, and we want to find the average. Well, how would you find that? So what that means is you would have to do, and just in case I've lost your attention, let me have it back. Let me have your attention for this point. How would you find the average amount? Well, that means out of 20 trials, you would have to go 20, choose 0, times 0.55, times 0, 1 minus 0.55 to the 20. And then you have to go all the way down to 20, choose 20. That means you'd have to go from 20, choose 0, 20, choose 1, all the way down to 20, choose 20, 0.55, 1 minus 0.5, 2/20. That's a lot. That would be a lot. It's doable, but that would be a lot. It turns out that since we have the number of trials, we have the probability of success, that since it's a constant, it's not changing, it turns out that the mean is really, or I should say equivalent to the number of trials times the probability of success. Can you believe that the sum of all of these is just n times p? Can you believe that that complicated of a scenario is actually just n times p? But it turns out it's true. It turns out it's true. And when I've had more time, I formally proved that in class. I'm not going to formally prove that. I've just kind of set it up. That that's what these mean. Okay, that's what they mean. For my numbers, I have 20 trials. I have probability of success 55. Okay. Was that 1, 10, 11? So the average is 11. So you don't have to do this, but you would have. And that would be pretty difficult, but we don't have to. It turns out that you can just use this formula. So I would have that formula written down somewhere. Okay, you're gonna want to use it. You don't want to have to do it the other way. All right. Standard deviation. The average turned out to be easy. Will the standard deviation turn out to be easy? Well, you hope so, but let's see what happens. Last time it was terrible. Okay, well, it turns out that the standard deviation is just n, number of trials, times p, times q. This is the probability of a winning. This is the probability of a loss. Okay? And it's just the square root like last time. But that's easy. That's easy to calculate. Number of trials for me is 20. Probability of success is 55. Probability of failure is the complement. Whatever your numbers are, you're just going to do the complement. Okay? And then take the square root of that. Hopefully that's clear. You want to have this formula. Now it tells you the formula in the example. It's also in the textbook, but you wouldn't want to have to find it the other way, right? That would be terrible. So it tells you what to do. You can imagine on a quiz or something, you would know. How do you know when to do this style of standard deviation versus the other? This is normal distribution. The other one wasn't normal. It was more of a histogram. How do you know when to do what? This is Bernoulli trials. Okay, it tells us the number of trials. It tells us the probability of success. So we can just simply use these equations to find it. Okay, easy. But how do you find the standard deviation with the intervals? With the intervals, you have to find the midpoint, and then you have to find the sum of the midpoint times the frequency, right? It's challenging, but you can do it. If I can do it, I did. So I hope that makes sense. Did I write something wrong? Which part?
B. B. What the difference between the standard deviation for A and then what you did for B?
So A is the mean. And it turns out, since this is the Bernoulli trial, there's 20 trials, and we have a probability of success as 0.55. And so for the mean, 20 times that.
Yeah.
That's okay.
Yeah.
For the standard deviation, it gives it, but because it's a Bernoulli trial, it's the square root of n times p times q. And what do we get? We get square root of 20 times the probability of success. For me, it's 0.55. I know that probably changes between the problems. And this would be 45, right?
Where'd you get 40?
It's the complement of this. So I think that's 45. The probability of not winning. Okay, from there, what do we get? So you get square root of 20 times 0.55 times 0.45. And I got 2.22. Anyone else? Okay. So that's the standard deviation. Standard deviation is approximately this. That part's okay. Okay. Now, probability of success, number of successes that lies within one standard deviation. So, what does that mean? Well, the average is 11, and the standard deviation is 2. So, what is the interval we're trying to figure out? So, if the average is 11, where are we going? So, 11 minus 2.22, I got 8.78. And 11 plus 2 is 13.7. So it seems like we're trying to find it from either 8 to 14 or 9 to 13. 9 to 13. Does the interval make sense? Online folks, don't hesitate to ask questions.
Did you added the two?
So I did
divide?
11, I added them, that's 13.78. I subtract, I got 8.7. This is the interval. Part B says the number of success lies within one standard deviation. I found one standard deviation. Okay, so let's get rid of this since we don't actually need it. But we do need the root. From there, let us find the probability of between those intervals. So I think that's going to be 9 to 13. How many trials? 20. So this is 20. Choose 9. Probability of success 55. 9 times. Probability of failure 0.45. How many times did we fail? Looks like 11 times.
Why is it 9 and 13?
9 and 13. We have the interval here. Round to 9, round to 13. So it's just 2. Interval of 2.
And why'd you round down?
Just doing an interval of 2 from 11.
Oh,
11 minus
okay.
2 is 9. 11 plus 2 is 13. So I'm going from 9 to 13 because my
Yeah.
standard deviation is roughly 2. Because I can only have a success or a failure. I can't have an in between with this. So that would be 20 choose 10, 20 choose 11, which is our average, 20 choose 12, 20 choose 13. Now from there, you'll see it on my notes, but then from there, I just plug in my calculator. For time's sake, and since I can't show it on the screen, I'm just gonna write down what I do. So that's probably getting 9, 10, 11, 12, 13. Because it wants within one standard deviation. So when I added these up, I got 0.7393 as the probability of getting within one standard deviation. If I drew my bell curve, that's the area under the curve between one standard deviation. That's the probability. So again, what did I do? It turns out you can just do the number of trials times the probability, since it's a normal distribution. That gives you the mean. That's easy. To find the standard deviation, it's the square root of the number of trials times the probability of success times the probability of failure. That's your standard deviation. Then part B, at least mine says the number of successes within one standard deviation. So my mean is 11. So I subtract and add my standard deviation on both sides. Now I have my interval. I can only win or lose, so I have to round. Just subtract 2, add 2. So 9 and 13. All right. Then I have to find my probability, my Bernoulli's. So 9, 10, 11, 12, 13. Find each individual probability and sum them up. Seems more complicated when I explain it than when I actually did. Are there any questions? Is there anything you'd like me to do again? I'd be willing to do the whole problem again if anyone is lost. Online folks, are we okay? Save a picture of it. Let me know if you're stuck. Number 4, manufacturing process produces an average of 4% of defective items. The company ships 15 items in each box and wishes to guarantee no more than one defective item per box. This guarantee accompanies each box. What is the probability that the box will satisfy the guarantee? What do we know? What do we know? Average, 4% defective on average, 15 items. This sounds like maybe that's the amount of trials. No more than one defective. What's the probability that the box will fail? So there's 15 items, but we want to know fail. We don't want to know successes. We want to know fails. So it's kind of like we're doing it backwards a little bit. And we only want to know if it fails or not. We don't care, if it halfway succeeds. That's not of interest to us. I think for this one, it would be easier to solve for the complement than to solve straightforward. what I mean by the complements, I think it would be easier to solve for the exact opposite of what we're asked. And then take that from 100% than to go straight forward. Because I think if we went straight forward, at least with my numbers, I would have to do a lot more work. So that's the way I'm going to do it. I'll explain it as I go. So I'm going to do the complement because I think it's going to be easier. So I'm going to take it from 100%. I'm finding the opposite of what it asked me to find. Okay. I have 15 items. That's like trials. I'm going to see if none of them fail. What's the probability of failure? For my numbers, it gave me 4%. So what does that mean? I guess this is 96%. Right? How many times did it fail? Well, this is not failing at all. 0 times, 15 times. Then it says no more than 1. So I'm going to take away the scenario where we do fail once. And this is the opposite of what I want. But if I take that from 100, I should get what I want. 15 choose 1 is just 1. Anything to the 0th is just 1. So that all goes to 1. Then what do we get? 1 minus 0.96 to the 15th minus 15 choose 1 is just 15. 0.04, 0.96 to 14. That would be the probability that the box will fail. No more than 1. 1 minus 0.96 to the 15th minus 15 times 0.04 times 0.96 to the 14th. I got it. 0.1191. Oh, 9. It says round to 3 decimal places. 0.1 for mine. Okay. The reason why I did the complement is because I think going the other way, it would be way more to calculate. I mean, you can do it. It'd be like 15 choose 2, 15 choose 3, 15 choose 4, 15 choose 5, 15 choose 15. So you have to do all of those, which you can. It's not that big a deal, but you don't want to. So I thought it'd be a little easier if I just did the complement. And the way I did it was I just took it from 100%. So I solved for the opposite of 1. Because I felt it would be easier. How do you know when to do the complement rather than the straightforward method? When the complement is less scenarios than the straightforward. Okay. Sometimes in certain questions, it's just it doesn't matter. In certain ones, it takes way more. That's the idea. Any questions about that? All right, let's move on to the next one. I wanted to go over number 5 as well. Probability, there's a lot of marriage, and it's kind of depressing. A lot of marriage and divorce for some reason. The probability that the marriage will end in divorce within 10 years is 55%. What are the mean standard deviation for the binomial involving 3,000 marriages? Okay, so I would say we don't really care about the interval of time. I don't think I need that with my numbers. The probability of success given the number of trials is given. They want the mean. Okay, well, the mean would be the number of trials times the probability of success for this. 3,000 times 0.5. So let's see what that is. 3,000. $16.50. Because it's a Bernoulli, I can use this. Standard deviation. What was that formula? N times P times Q. That's what we want to use. All right, so let's do it. Number of trials for me, it's 3,000. I'm not sure what it is for you. For the probability of success, 55, and the probability of failure, 0.45. There we go. I guess failure and success is relative to what you mean by divorce and non-divorce. But I get it, 27.24888539. Round to 3 decimal places, 2724. On that one. The probability is 45% that the marriage will end in divorce within 20 years. What is the probability that out of 7 couples just married in the next 20 years, none will be divorced, all will be divorced, exactly 6 will be divorced, at least 6 will be divorced. How many couples do I have? It looks like I have 7. So I think n equals 7. Probability of divorce is 0.45. So that means that the probability of non-divorce would be 55%. So it's a little bit nicer in this equation. Okay, but this asks for part A, none will be divorced, which is different. They won't. It said find the average. Okay. So for that, I think I have 7 couples. I'll write this as A. 7 couples, none will be divorced. Probability of divorce for my numbers is 45, which didn't occur. 55, and that occurred 7 times. 7 choose 0 is 1. 1. So you just get 0.55 to the 7th. So on, you got a round somewhere. Okay, so that's part A. Part B is all will be divorced. Since I have 7, all of them would be 7. 0.45 to the 7th, 0.55 to the 0th. 7 choose 7 is 1. There's only one way you can choose all. Anything to the 0th is just 1. So that's 0.45 to the 7th. Now part C, at least my C, says exactly 6. 7, choose 6. 4, to the 6. 0.55 to the first. 7 choose 6 is just 7. So this is 7 times 0.45 to the 6 times 0.5. See the value there. At least 6. Well, how can you do at least 6? That would be 6 and more, but we only go up to 7 for my numbers. So I'm just gonna do 6 and 7. And since I already did 6, and I already did all of them, couldn't I just add those? If I did all would be divorced, and I already did 6, I should be able to add those two probabilities to get this. So I think you can add this, which is 6, and then all of them be divorced. And that would be the probability that it would be 6. 0.0037 plus 0.032357. So just because of previous work, I was just add those together. Any questions, comments on that?
Last part, the 6 and 7.
So it says the probability at least 6 will be divorced. So I already calculated 6. And I already calculated all. And that's the only thing I could possibly have to be 6 or 7. So I just added those two together. If it's 7 total and it says at least 6, I already calculated 6, I already calculated all of them. So I just added those two together. Just put these two together. I just add them together. That's it. Given the normal distribution with a mean of 100, standard deviation of 10, find the number of standard deviations. The measurement is from the mean. Number of standard deviations from the mean. That is called the z-score. So z-score tells you how many standard deviations you are from the mean, the average. It has a formula. Whatever the particular value that you're asked about or interested in, minus the mean over the standard deviation. Okay, that's the formula. It's just a formula. So this tells you how many standard deviations you are away from the center. In this particular version of the question, it's 118 is the value we were asked about. The mean was 100 and the standard deviation is 10. So this is the z-score, and the z-score tells you where on the normal distribution you are. So 118 minus 100 divided by 10 is 1.8. So this is 1.8 standard deviations from the mean. So it's over here. Here it is. It's kind of like it's over here, somewhere in there. It's between 1 and 2 standard deviations to the right. But it's just a simple formula. Take the value minus the average, and you divide it by the standard deviation, and that tells you where on the normal distribution curve you are. You can have, it will show up negative if it's to the left. It'll show up negative if it was to the left. And you can do this with all kinds of things. One of the lessons I teach in every class is like baby weights. Baby weights is a normal distribution with an average of like 7.5 pounds. It's average, and then babies kind of trail off at the end. You have very few babies that weigh 12 pounds when they're born, and you have very few babies that are born less than 3 pounds when they're born. Okay, given a normal distribution with a mean of 100 and a standard deviation 10, find the number of standard deviations the measurement is from the mean. Number of standard deviations from the mean. That's the z-score. Z-score is x minus the mean over the standard deviation. In this, they gave me 126.7. I had an average of 100 over 10. So that's 26.7 divided by 10. That's just 2.67. That's the z-score. That tells you where on the curve you are. You took like an SAT at some point, an ACT. That's how they sort us. That's 2. It's over here. It's over here somewhere. 2.5. So that's pretty high up. Yeah, if you've taken any of those standardized tests like SAT, ACT, I had to take all those. I had to take the GRE. It sorts you through percentiles. But it's fairly easy to calculate. That was 8. The next one I wanted to go over was 11. Can't remember what the deal with 9 was. 9. Yeah, I felt like you could get this. Complete the following graph. Normal curve. The mean is always the center of the curve. Yeah, the units along the x-axis measure the distance of the standard deviations. I could do this when I was going to skip to 11. Use the pop-up below to find the area under the standard normal curve from 0 to 1.8. Click the icon to view the area under the standard normal curve table. This is an interval from 0 to 1.8. What is 0 and 1.8? What is that? Is that the mean? Is that the standard deviation? Is that the z-score? Is that hot dogs? What is that? That's the z-score. So from 0 to 1.8. What is the area under the curve? Our mean plus the standard deviation plus 2 standard deviations. And this is 1.8, so it's over here somewhere. We want to know the area under this curve. How can you find that? What you can do is you can look at the probability table, which is what it gives us. So look at that. It gives it to me. So it's not something I have to memorize, and it's not something I have to calculate. It's just something I have to look up. So I want to look up 1.80. And where is that? 1.80. It's right there for me. That tells you the area under the curve. So it gives us that. That's not something we have to memorize. That's something that's given to us. But we can look at that, find it. You just have to know where to look. Okay, so z-score 1.8. So from 0 to 1.8, 4641. So I got that from clicking. So to get that, I'm going to click this little matrix thing here. That gives you that table. And there you are, 4641. that okay? Question?
So the 1.8 is on the left side of the
Yeah.
table.
Yeah. So this gives you the z-score. And 1.8. And then that tells me the probability.
Oh, and then if you have another decimal,
If we have, which we will in other examples.
yeah, mine's like 2.64, so you just go over to the.
If it was,
4 part.
if it was 2.64, I would start at 2.64, 0, 1, 2, 3, 4. So I think I would go here.
Okay.
I think. I'm looking without dragging, but I think it would be there.
Okay.
Okay. That table is not something we have to memorize. That's something if needed will be given to us. We don't have to memorize that. Online folks, let me know if you have a question. Good stuff. When we get to number 20. It's 19. Pop-up window define the area under the standard normal deviation from negative 1.27 to 0. Okay. So where on the curve am I? Negative 1 standard deviation, 2 standard deviations. So I'm somewhere over here to 0. I think this would be 0. Right there. Let's look it up. So we want negative 1.27. Looking at the table, it's not something I have to calculate. Sorry. So I need to look at this 0.07, so 1.27. So I'm over in this column. 1.27 is, let's see if I can do it. This is really hard on the TV screen. 0.3980. A lot easier on the computer screen. Yeah, okay. Cool. All right, that's all I need from that. Zero. Not from the table. Yeah, yours might be different. Zoe's just different, but still okay.
Yeah.
Okay. I think, it just takes a little practice looking, but it should be okay. All right. Oh, we're at 35 here. I think these will be okay. Yeah, I think you'll be okay. If not, I'll make a video. The only thing that's different here is that you have an average of sales. That's your average given the standard deviation. You want to know what the expected is for this or more. Okay, let's try this one. Since it's a word problem, let's do this one. So z-score x minus the average over the standard deviation. My numbers, we want to know where this lies. That'll tell us where on the curve it lies. So I got a z-score of 2. What's the table say about that? So we're getting a z-score of 2 corresponds with 0.4772. But this says or more. We have to or more. I want to do. It says or more. I'm going to take 50% minus 0.4772. Be good. 0.5 minus 0.4772 equals times 2.28%. That's because it wants more than. If it wanted less than, that's what we had. If it wanted less than, that's what the z table is. This is more than. So we're finding from the 50% mark or more, where is it? So the difference gives me or more than. That's the idea. Let me draw it out. That's what it says. Hopefully. Deviations 2. So we want to know or more. What the z table told us was this. Z table tells us from 50% to that point, but we want or more. So we have to take that part away. Take it away, you're left with what you want. So because it says or more, that's what you want. And that's pretty much always going to happen. If you get a question like this and it says or more, you're going to take the column. That's the idea. There. Need to try to do problems. I don't think I have time for 3 more. So which ones do I need to do? There's too much homework. I think if I do, I think I've done all the really hard ones. Let's try the last one and see where we'll end up. We have time for another one. We have time. Okay, a binomial experiment consists of 600 trials with the probability of success 0.4. What is the probability of obtaining 246 or more? Easily pieces rule of thumb check. One computing, adjust the given interval by extending it by 0.5 on each side. Okay. 246. 600 trials. So N equals 600. Probability of success by 4, so probability of failure 60%. One or more, 246, and it says adjust the given interval by extending it by 0.5. So the reason you do that is because you want to include that interval and everything in there, so you just extend it a little bit. It's nice enough to let us know that we need to do that. Then we have the table once we get there. So I have N equals 600. I have P equals 0.4, which means Q equals 0.6. Let's find the mean, which is N times P. For my numbers, that's 600 times 0.4, sorry. 600 times 0.4, 240. And for the z-score, we need and the standard deviation. What's the standard deviation? Square root N times P times Q. 600 times 0.4, 0.6. Okay. The root 600 times 0.4 times 0.6. It's 12. Yeah, right. Let me try it one more time. Square root 600 times 0.4 times 0.6. 12. Okay. So what is our z-score? 246 or more. So we want to include that. So we want to extend the range. So 246 minus 0.5 is 245.5. We're extending it like it tells us to. 245.5 minus the average, 240 over the standard deviation, 12 gives us the location. 245.5 minus 240 divided by 12. I'm finding 0.45. Oops, said the right number, right wrong. 8 through the page. Yes. Okay. That's the z-score. Now let's go to the table. Look up that as best we can. Looks like I'll have to cut it off at 346. Would be closer since I have to cut it off. So we're going to call the z for 0.46. That's the best I can do, and that's closer. So that implies 0.1772. So far, so good. Is that okay? I know I'm slowing down because I realize how fast. Does it make sense? We've technically done everything so far, but I didn't know if I'm going too fast.
And you got the 0.6 just by subtracting 1 minus 1, right?
Oh, I got the fail. Yeah, these have to add to 1.
Okay, yeah. Okay.
So that's probability of failure. Yeah, here you go. Number of trials, probability of success, probability of failure. We have the mean, we have the standard deviation, and then the z-score is the value minus the mean over the standard deviation. It told me to extend by 0.5 because I want that interval. It told me to, so I subtracted. So it told me 246. It says extend it, so I'm going to. So now it's 245.5. I'm extending it a little bit because I want to include all of it. It told me to do it, so I did it. value minus the average divided by the standard deviation. That tells me the z-score. The z-score, I just rounded the best I could, and I found my
So
x is the value.
minus, and the z-score is x minus n.
But minus the average, mu.
So why does x equal 240, but you have it plugged in as mu?
Yeah, that's right. 240, 240, it's the same number. Let me get rid of this for a second. That's the same number.
Yeah, I'm just confused because it says x minus that versus the z-score.
So this is the value. This is the value, 246. This is the average. So the value minus the average over the standard deviation. Now, why is this 246 and I plugged in 245.5? Why did I do that? Because it told me to extend it by half. So I did. So I extended it just a little bit. Now I found the z-score. That's where on the bell curve it is. Look up on the table, find the probability. That's what I did. And then the last piece is to actually answer the question. When computing the probability, just to give an intro on each side, what is the actual question? What is the probability of 246 and more? And more. Probability 246 extended and more. And more means we got to find the complement. Okay, so let's find the complement. So that's 0.5 minus 0.1772. All right, so 0.5 minus 0.1772. I get 0.3228. Rounded to 2 decimal places, I get 0.2. Online folks, what questions do you have? Save a picture of my work. Any questions? Not yet. Well, there's only 1 minute left. I will just let you email me. I will post these notes, screenshots, and everything. Tonight usually takes a couple hours for the video to render. And I will post it, okay? All right, stick around if you have questions. If not, I'll see you next time. Next time we review. So this is the last new content. Next time we review, but that means, you know, next time is probably more important than this time. So you definitely want to come, because then pretty much next time I'll teach you the test, right? So you want to come next time. All right. Until then, I'll see you.